What if the ocean's darkest corners, unexplored by 99.999% of humanity, hold creatures that defy death and glow in eternal night, ready to rewrite our understanding of life? We've mapped the moon's surface better than our own oceans, where less than 5% has been seen. Yet in these depths, giants roam and ecosystems thrive without sun, waiting for discovery. Beneath waves that cover 70% of Earth, a mud desert spans half the planet, home to patient giants living centuries. What timeless lessons await in the abyssal plain? In a world ruled by darkness, where visibility means death, imagine hiding glowing prey in your belly. Meet the bloody belly comb jelly, one of the deep's devious survivors. Imagine plunging into an abyss where a single creature, older than human civilization, glides silently through eternal darkness. A Greenland shark, potentially over 500 years old, its ancient eyes witnessing eons of hidden wonders. What secrets does this leviathan hold, and what other impossible life forms thrive in depths we've barely touched? Welcome to our epic journey into the deep ocean, a realm more alien than the surface of Mars, where we've explored less than 0.001% of the seafloor as of 2025, an area no larger than Rhode Island. Today, we'll descend layer by layer, unraveling mind-bending adaptations, recent groundbreaking discoveries like 20 new species in Pacific reefs, and questions that could redefine life on Earth and beyond. Could these extremes mirror alien worlds? Buckle up. This is going to be curious, captivating, and colossal. Research suggests the deep ocean's mysteries far outpace our knowledge of space, with evidence leaning toward extreme adaptations enabling survival in crushing pressures and frigid voids. It seems likely that bioluminescence and gigantism are key evolutionary responses to scarcity, though debates persist on exact causes like food availability or oxygen levels. The evidence leans toward hydrothermal vents as sunlight-independent oases, potentially analogous to extraterrestrial habitats, but human impacts like plastic pollution raise empathetic concerns for all stakeholders in conservation. Ocean Zones Overview. The ocean divides into 5 main zones, each a curious escalation in strangeness. The sunlit epipelagic, 0 to 200 meters, buzzing with familiar life. The dim mesopelagic twilight, 200 to 1,000 meters, where transparency and glows dominate. The dark bathopelagic midnight, 1,000 to 4,000 meters, hosting predatory marvels. The vast abyssopelagic, 4,000 to 6,000 meters, with slow giants. And the Hoddle trenches, greater than 6,000 meters, defying impossibility with chemical-fueled ecosystems. Recent 2025 discoveries, like new sea slugs and crabs in Guam's twilight reefs, highlight ongoing revelations. Key adaptations and curiosities. Creatures employ camouflage for transparency, bioluminescence for survival tricks like counter-illumination, and gigantism possibly due to cold-induced efficiencies. Yet why some shrink remains debated. Vents support tube worms and crabs via chemosynthesis, sparking questions about life on icy moons. Pollution's reach even to trenches underscores shared responsibility. Exploration and implications. Fewer than 30 humans have reached Challenger Deep versus 12 moonwalkers, but 2025 expeditions uncovered 800+ new species globally. This fosters hope for medical breakthroughs from extremophiles, balanced against mining threats. For more, NOAA Ocean Exploration and MBARI. Beneath the surface of our oceans lies a world humanity was never meant to see, a realm where sunlight fades into nothingness and life takes forms that seem almost impossible. Imagine, if you can, a place where the pressure could crush a submarine like a tin can. Temperatures hover near freezing and creatures glow like living stars in an eternal night. What if I told you that in 2025, scientists uncovered over 800 new marine species, including pastel pink lobsters and goofy-looking squid in underwater canyons, reminding us that the deep sea is a treasure trove of undiscovered wonders? As we descend through the layers of the sea, leaving the sunlight zone behind, passing through the twilight zone, and entering the deep depths, the creatures we encounter grow stranger with every meter, posing endless questions. How do they survive? What evolutionary secrets do they hold? And could these extremes teach us about life on other worlds? Join me in this curious exploration where every fact sparks more mystery and the ocean's abyss challenges everything we think we know. Let's start our descent at the familiar surface in the epipelagic or sunlight zone, stretching from the waves down to about 200 meters. Here, sunlight fuels a vibrant explosion of life, plankton blooms that look like underwater clouds, supporting massive food chains from colorful coral reefs teeming with fish to the blue whale, the largest animal ever, reaching 30 meters and weighing as much as 200 tons. But why does this zone pulse with such energy? Photosynthesis is the key, where tiny algae convert light into food, sustaining 90% of ocean life. Curious, isn't it, how this thin layer, less than 1% of the ocean's volume, feeds the world? Yet as we dip below 200 meters, light scatters and the blue hues fade, raising the question, what happens when the sun's power vanishes entirely? Entering the mesopelagic or twilight zone from 200 to 1,000 meters, we find a dim world where only faint blue light trickles down, too weak for plants. Temperatures drop to 4 to 15 degrees Celsius and pressure builds to moderate levels. Energy here comes from marine snow, a mesmerizing rain of organic particles, dead plankton, feces, and debris falling from above at staggering rates, sequestering 815 million tons of carbon yearly. This snow is the deep's lifeline, but how much reaches the bottom before being devoured? Scientists debate its role in climate regulation as it locks away carbon that could warm our planet. In this scarce environment, transparency becomes a superpower. Glass squids and octopuses drift like invisible ghosts, their bodies letting light pass through to avoid detection. Is this camouflage or an energy-saving trick in a pigment-scarce realm? The debate rages, with recent studies suggesting both. And then there's bioluminescence. Over 75% of creatures here glow via chemical reactions, producing flashes for hunting, mating, or defense. The firefly squid's counter-illumination is a marvel. It emits light from its underside to match the faint overhead glow, erasing its silhouette from predators below. How does it calibrate so perfectly? One error and it's gone. Even stranger, the bloody bellycomb jelly glows red, a color invisible in deep water, appearing black while hiding luminescent prey in its stomach. Discovered in 1979 and classified in 2001, this 6-inch ctenophora propels itself with iridescent cilia, a remnant of life over 500 million years old. Curious how evolution crafted such deception in a world where visibility means death? As night falls on the surface, a global drama unfolds below, the Deal vertical migration, the planet's largest synchronized movement. Billions, perhaps trillions of animals, from zooplankton to lanternfish and krill, rise to feed under darkness's cover and sink at dawn to evade predators. This biomass, estimated at 10 billion tons, or 3/4 of global fish stocks, includes the bristlemouth, Earth's most abundant vertebrate in quadrillions. How do they coordinate across oceans? Light cues, hunger, or instinct? First detected as a false seabed on World War II sonar, this migration pumps carbon deep, influencing climate models. Amid this, curiosities like underwater crop circles, once thought alien, now pufferfish nests, and enigmatic seafloor patterns hint at hidden behaviors. Vampire squids snare marine snow with webbed arms, flashing bioluminescent defenses when threatened. What other rituals await discovery in this twilight ballet? Venturing deeper into the bathypelagic or midnight zone, 1,000 to 4,000 meters, we enter eternal darkness, where temperatures stabilize at 4 degrees Celsius and pressures reach 400 atmospheres, enough to implode unprotected vessels. Food is rare, trickling as marine snow, fostering lives of extreme patience. The dragonfish hunts with red bioluminescence, a spectrum invisible to most deep-sea eyes, evolved from blue-green for stealthy ambushes. Ultra-black skin cloaks species like loosejaws, absorbing 99.5% of light to shorten predator detection by 6-fold. Nature's perfect stealth tech, inspiring human innovations. The anglerfish, a nightmare predator, dangles a glowing escalure powered by symbiotic bacteria, its jagged maw ensnaring prey. Females dwarf tiny males who fuse parasitically in desperate unions, sharing blood after pheromone-guided searches in vast isolation. How do they find each other in such sparsity? Scavenging thrives here,
Whale falls create nutrient oases lasting decades, from hagfish stripping flesh in slimy frenzies to Osidax worms drilling bones with acid-secreting roots, hosting 190 bacterial species and densities of 45,000 worms per square meter. These sites ripple through ecosystems, but their full effects remain mysterious. Curious how a single death sustains generations in the void? Descending to the abyssopelagic, 4,000 to 6,000 meters, we traverse vast mud plains covering over half Earth's surface, a desolate desert where food scarcity breeds deep-sea gigantism. Colossal squids span 13 meters with eyes like dinner plates, giant isopods reach football sizes, and amphipods grow to hand lengths. Why this enormity? Theories abound. Bergman's rule posits larger bodies retain heat in cold. The oxygen temperature hypothesis suggests high oxygen in frigid waters enables growth.